This is an ITX form factor motherboard designed to be used in a NAS, and it features the Intel Celeron N5105 CPU. Now, I did a review recently of another N5105 motherboard, and it's this guy right here. So there are some similarities and differences, and I'm going to kind of go through them and compare them. I'm not going to go through the full gamut of testing like I did with this guy. I'll just reference you to that because the CPU, the chipset, and majority of the components are similar, and I did do some basic evaluation on this board, and I will share those benchmark results at the end of this video. While the N5105 is not necessarily the most powerful CPU out there, it is definitely a lower power option, and also it's great for a budget build. And it can handle up to, at least that I've seen, at least 12 disks in a RAID 60 or RAID 10 configuration. It can operate as a media server, and just a general good overall budget option. There are higher end NAS boards out there. Of course, they cost more money. And speaking of which, I do have this Intel N305 board, which is by a company called CWWK. Has some more options on it. Now, this is an 8-core 8-thread Intel CPU, and it is a 15-watt TDP, and it has the heat plate on here, but you need to put a cooler on here separately, and I'll have that. But I'm going to be doing a review of this board shortly, so if you want to get notified of that, go ahead and subscribe. And just to give you a general overview right now, this has 6 SATA ports, just like this other guy here, a PCIe 1X slot, a DDR4 So-DIMM slot, and then, so it has the 4 2.5 gigabit Ethernet Intel ports here, a USB 2.0 full-size DisplayPort HDMI, and then USB 3.2 ports, both a Type A and a Type C. Now, this motherboard is made by a company called BKHD, and they also make this N100 variant of the motherboard that I also reviewed along with this N5105 motherboard previously as well. Now, this one's made by a different company. To be honest with you, I don't know what company that is. It seems like it's a no-name brand. I got it off of AliExpress. But this one definitely is a BKHD. See on the name there, as well as over here, BKHD right on the board. So what caught my attention on this motherboard is the fact that it actually has a PCIe slot, and it's a 4X PCIe slot, whereas the other version here does not have a PCIe slot. But you'll notice that this one has 2 M.2 slots, this one here and this one here, whereas this one only has one M.2 NVMe slot, but it does add the 4X PCIe slot. The N100 variant also has a PCIe slot, but it's only a 1X. Now, the N5105 and the N100 only support PCIe 3.0, so a 1X slot will run at about 1,000 megabytes per second each direction. However, the N5105 only supports up to 8 PCIe lanes, so I was a little skeptical about this 4X slot. And actually, if you take a look at the specifications on the website, because thankfully BKHD actually has a decent website, and they do have some form of support. So if you look here, you can see the N5105 here, and they do have product specifications. And if you scroll down in the specifications, you see here expansion slot 1 by PCIe X4 slot with an X2 signal only. Now, since we're already on their website, if you take a look here, they do have a BIOS file for download. The current BIOS is installed on here. That's on the website, version 208. They also have the Windows 2.5 gigabit Ethernet NIC drivers here, which is good because when you install Windows 11 or Windows 10 on this board, just like the other board, the i226V chipset is not detected with the Windows 10 or Windows 11 installation even after all the updates. So you definitely need an external driver. Now, you can also download this directly from the Intel website. Definitely something that you're going to want to consider when you use this board with Microsoft Windows. Now, if we do a quick comparison here, we can take a look at the ports in the back of these guys, and they both have a USB 2.0 ports, 2 of them, full-size DisplayPort and HDMI, and go over those resolutions in a minute. And then the USB 3, 2 of those in Type A, and then it's the 4 i226V 2.5 gigabit Ethernet ports here. Now, looking at the CPU, clearly that the heat sinks are a little bit different, and we'll go over some noise profiles on both of these guys. And also, they both take the DDR4 So-DIMMs, like these guys here, right? And it does accommodate 32 gigabytes. I'll show you that too. Now, I know in my original video for this motherboard, I said it did not accommodate 32 gigabyte chips. It does accommodate 32 gigabytes. However, it can take up to 2 minutes when you turn it on for it to even detect it. There's no activity on the screen. That's why I thought it wasn't accepting it. So after a minute or so, I said, okay, it's just not accepting it. But if you give it enough time, it will eventually detect the memory and boot into Windows or Linux or wherever, then after that when you reboot it should be no delay there. Of course, these are the 24-pin ATX power connectors here, and then also a 4-pin power connector for the CPU. Now if we take a look at the SATA ports, they both support 6 SATA ports, and that's good clearly from a NAS standpoint, right? You want as many SATA ports as possible for as many drives as you want to run on it, and it's good to have it natively on the board so you don't have to use any other I/O. Now this BKHD board comes with an ASMedia 1166 ASM1166 chipset, which is right here, and this board here comes with the J-Micron JMB585 chipset, which is under here. Now the ASMedia supports up to 6 SATA ports natively, whereas the JMB585 only supports up to 5, and so it has to draw the extra SATA port control from the CPU itself. Now I'm going to swap out this N5105 for a second, the old one, for this N100 version of the motherboard that I reviewed previously. And it is also made by BKHD, and if you notice that this one has a PCIe 1X slot on it. Now if you look at the N100 board here, it has a PCIe 1X slot, but it's open-ended so that you can fit a card in there that is larger than just a PCIe 1X card. It's a good feature to have. Additionally, if you look at the SATA ports here, they separate these far enough so that you can actually slot in a PCIe card so that you don't interfere with the SATA ports. It still is a little bit of a tight fit with SATA connectors with clasps on it, but it allows you to actually make the connection. Now conversely, on this N5105 board, so we take a closer look at the PCIe 4X slot here, it actually has a wall right there, so that way it prevents you from installing a card larger than PCIe 4X, which is not good. Additionally, the SATA slots, if you look at the SATA ports here, are a lot closer together than they are on the N100 board. So it's a little bit of a mystery to me why they chose to go with a 4X slot that only accommodates PCIe 2X. Additionally, why they went with a closed-ended slot here and preventing you from putting in anything larger than a 4X card. So for example, if you take like this GPU and it's a 16X PCIe card, you can't slot it in there at all. Now by using this M.2 to NVMe adapter, I can easily slot this in because I actually put accommodations on here for different length slots. But if I put this in here, it's a tight fit to get in between those SATA ports there. Now this one does fit only because I've inserted and removed this number of times. Additionally, if you go to and plug in a SATA cable, right, especially with a clasp on it, you can see here it kind of makes it touches off to whatever PCIe card is in there and kind of makes it flex out a little bit. So that's not good either. So if you want to slot in a larger card, like let's say this SAS controller, you can't even fit that in there. So your only option really is to go with some sort of adapter, like this guy here. It goes from 4X to a 16X slot. And I have not had a lot of luck with these. This one actually reduced performance significantly when I used this. I also tried another one, went directly from the 4X to a 16X, like on top of each other like this, right? But that one gave me all sorts of issues too. So your only other real option is to go in there and cut away that wall there, like with a hot knife or something, and I might do that. Just I wanted to get through all the benchmarking before I did that in case I screw it up and make the board inoperable. So I have this WD Black SN770 M.2 SSD and this M.2 to PCIe adapter, and we're going to go ahead and take a look at that 4X adapter within Ubuntu and check the link speed there. Now we can dump the LSPCI device list to a text document on the desktop. Now pull up the LSPCI document, and the SN770 is identified as a SanDisk device, which would make sense. I believe it's got the same controller as a SanDisk SSD. But if you go down here to link cap, you can see here it's a width of X4. However, down here at link state, it shows it as downgraded to a width of X2. And we can verify that by running an HDParm to the SSD. And there's our WD Black SN770. So now we can do a sudo, and there we're only getting about 1432 megabytes per second. Now I swear previously I ran this and I was getting about 1700 megabytes per second, so I ran kdiskmark here. You can see that the read performance test is definitely 1700 megabytes per second. In any case, we can see that it's faster than a 1X PCIe 3.0, which would only be about 1000 megabytes per second max, and a 2X would be about 2000 megabytes per second max with some overhead here. So we can verify that it is more than PCIe 1X, but definitely no more than 2X. So let's take a quick look at the BIOS here. You can see here it's version 2.08, which is the latest version showing on the BKHD website. And if you go over to the Advanced tab here, you can see there's a ton of options through here. I'm not going to go through all of them, but I'm going to show you a couple of them that I tried. However, I realized that many of these settings, when you go to adjust them in the BIOS, it really doesn't take effect on the hardware at all. Going over to chipset, you can see the PCI Express configuration where you've got your X2 port, which I believe is the 4X slot running at X2 speed, and then PCIe 1X to SATA, to the SATA controller, and then the PCIe X1 M.2 SSD, and then your PCIe 2.5 gigahertz LAN. SATA configuration, I went in here and I actually disabled this, and it didn't seem to have any effect on the SATA ports, so that didn't seem to matter. Security, pretty bog standard. And boot priority. Okay, so now if we go into the power and performance menu, go to CPU, and then you go down here, you can see the C states are enabled. However, at idle, the motherboard still consumes about 20 watts with just RAM and an M.2 SSD connected to it. So I'm not sure why that is. I still have not been able to figure that out yet. Now if we go under hardware monitor here, we go to smart fan function. This is set to automatic. You can set it to software mode, but I adjusted this several different ways, and the fan itself actually runs at 100% that I can tell all the time. Okay, now I'm going to do a noise level test as well as get an idea for the idle and boot up power consumption using this guy here, and then I've got my decibel meter here. And I'm going to go ahead and boot up into Windows, and I'm using the EVGA 500 Gold power supply here. And as noted, if I adjust the fan profile within the BIOS, it doesn't make any effect on this, so it's pretty much running full tilt, but you'll get an idea for how loud that is. So I'm going to let this idle here for a little bit so you can get an idea for the baseline of the room. Then I'll go ahead and power it on and boot into Windows. Now I'm not going to say that the fan is quiet. It's not obnoxiously loud, but it's definitely audible. And I'll try to get a recording of it closer up here with the phone. Now if we compare this with the other N5105 board, so whereas on this board here you have about a 4 decibel increase in volume, and here it's almost negligible measured at this location. Now that we're on Windows, let's take a quick look at the specs here. You can see the CPU clearly N5105, and the RAM is 32 gigabytes, so it's all been detected, 2933 megahertz. Now we go into networking settings. You can see here all the Ethernet ports, 2500 megabit link speed. N5105 NAS Motherboard with 4X PCIe slot connected to DisplayPort out through Windows, and the maximum resolution is 4K at 60 Hz. N5105 with 4X PCIe slot connected to HDMI port to Windows, and it can support 4K 50 Hz at max. Alright, so I have this motherboard loaded up here. You can see I've got M.2 SSD here, the Samsung 970 EVO Plus, and then also the PCIe adapter to M.2 card with a WD Black SN770 M.2 SSD. We got 6 SATA drives connected to this. They're all Samsung 850 EVO SATA SSDs. And then I also have a USB to M.2 adapter with this Celeron SSD here too as well, so we can test all the I.O. Then of course we've got the 4 Ethernet ports here. Alright, we're going to go ahead and take a look at the block devices here. You can see here we've got SD A, B, C, D, E, F, G, and H. And it looks like A, B, C, E, G, and H are the SATA SSDs. Alright, so I'm going to go ahead and run the HDPARM read test on each of those SATA SSDs. And there's your HDPARM results for each of the 6 SATA ports with those Samsung 850 EVO SSDs. And it looks like it's up where it should be. Now I'm going to create an MD admin RAID 0 or stripe array with all 6 of those Samsung SSDs. And so we can check for the maximum throughput of this controller through that PCIe 3.01x lane. Alright, so it looks like we have our RAID array set up as MD0. We can go ahead and do an HDPARM read test. And there we have 844 megabytes per second. Alright, now let's go ahead and take a look at the WD Black SN770 through the PCIe port. And there you can see you get about 1400 megabytes per second. A little bit lower than I'd expect, but it's definitely above greater than one lane of PCIe. Now we'll go ahead and check the M.2 NVMe port. And there we get about 716 megabytes per second. And now we'll check for the USB port. There you can see we have 880 megabytes per second. So it's definitely a 10 gigabit port. Alright, I'm going to go ahead and validate these through KDiskMark as well. And we'll do the RAID array first, just a sequential test real quick. So there's our results. And you can see it's about 860 megabytes per second. So that matches pretty much what we got in HDPARM. Next we'll test the M.2 slot. And there's the Samsung 970 EVO Plus and the M.2 NVMe slot. Now we'll check the WD Black SN770 and the PCIe 4X/2X slot. And there's your performance through that PCIe slot. And now we have the USB adapter here. And there's the result for the USB port to the M.2 SSD adapter, and that looks like it's right up where it should be, about 1000 megabytes per second. And if we take a quick look at the network adapters, you can see they're all 2500 megabit per second. We can verify the RAM real quick. Scroll up here, you can see memory is 32 gigabytes, or right there. As far as transcoding is concerned, with Plex Media Server, as long as you're using the Linux version with hardware encoding enabled using QuickSync with the Intel integrated GPU, it was able to manage 4 simultaneous transcodes of 4K HDR videos to 1080p without issue. Now I did notice in one instance a slight hiccup pause at an existing video stream when I started a new video stream, but it was short and continued to play back just fine. Now taking a look at some benchmarks and comparisons. First up we have the power consumption of the board itself, and this is the power draw from the wall with a single M.2 NVMe SSD, 2 8GB of DDR4 RAM sticks, and 1 Ethernet port plugged in using a 500 watt EVGA gold power supply. Now we're comparing this with the other N5105 generic motherboard that I reviewed previously. The pink is the N5105 BKHD board that we're reviewing this time. The blue is the generic one, and both of them idled at around 20 watts, and even with C-states enabled and low power setting in Windows or Linux, for whatever reason it would run at about 20 watts. I couldn't get it to go any lower. Now at load, the generic board did not exceed 30 watts, whereas this board itself for some reason would hike up to about 34, and even in this case of Linux here to 38 watts. Now I did run Cinebench R23 on this device and compared it with the other boards that I've run in the past. And you can see here, compared to the N5105 generic board, it's running comparable, maybe a little bit slower, but not by much. However, I did record some values for the CPU throughout the test. And you can see here, over on the right, we've got the values for the core clocks, and everything else are the values you should read on the left for the CPU usage, CPU temp, and CPU power. Now if you take a look, obviously the CPU core usage is 100% across the way, and then the core clocks were right about 2800 megahertz as well, and then the CPU package power is about 15 watts. And if we take a look at the temperature here, it maintained temperature pretty well at about 62 degrees Celsius throughout the test. Now I did run this with the fan disconnected, just curious to see if this actually needed any active cooling in order to run, even if it had a slightly higher temperature. Well, if you take a look here, the solid lines are the ones that we just looked at a second ago, and the dotted lines are the test run with the fan disconnected. And if you take a look here, the CPU did maintain 100%, no problem. But when you look at the core clocks, which is the pink here, the solid line is with the fan, the dotted lines are without the fan, and clearly the performance tanked a little bit down to about 2300, 2200 megahertz compared to the 2800 megahertz with the fan. And if you look at the temperature, which is this dotted green line up here, you can see here it hit up to over 100 degrees Celsius. So clearly there's some throttling going on there. Now here I compare this motherboard with the generic board I reviewed previously. Again, the solid lines represent the current BKHD board I'm reviewing in this video, and the dotted lines represent the generic board I reviewed previously. And taking a look at the CPU usage, it's 100% across the board for both. And then we look at the core clocks. The generic board actually ran a little bit slower, about 100 to 200 megahertz slower. And when it came to temperatures, the generic board ran a little bit hotter. More interesting is that we see that the CPU package power, the CPU itself, drew about 15 watts with the BKHD board, but only about 10 watts with the generic board. Now, we would think that we'd end up with a better Cinebench score, right? Well, you go back and look at the benchmarks here, you can see this actually scored a little bit less than the generic board, so I'm not sure what's going on there. Here is a quick overview of the 2.5 gigabit Ethernet speeds, where I wrote 10 1 gigabyte files across the network to and from the device over the 2.5 gigabit Ethernet ports. Now, 2.5 gigabit Ethernet should run at about 280 megabytes per second realistically in a file transfer scenario. You can see they're all pretty much jumbled up here, 260 to 280 megabytes per second, which is pretty normal. However, you look at the generic N5105 motherboard in Windows 11 write test, and that was performing down at around 235 to 240 megabytes per second. And weirdly enough, the BKHD board in Ubuntu, the read test was actually performing at about that level too. Can't understand why, but that is what it is. Otherwise, I did not find any other issues with transferring files over the 2.5 gigabit Ethernet port. It was definitely running at about 250 to 280 megabytes per second consistently. Now here's a quick glimpse at the M.2 and 4X PCIe slot read performance. And the blue represents the generic board, whereas the purple and the pink represent the BKHD board in this review. Now the dark blue, light blue, and the purple are M.2 slots, whereas the generic board had two M.2 slots. That's why you see these two here. And then the BKHD board just has one. And those are all at PCIe 3.01x speed, which means it should not exceed 1000 megabytes per second. This shows us that we're actually running around that threshold for that 1000 megabytes per second on those M.2 slots across the board. And then the PCIe 4X slot, which is actually running at PCIe 2X speeds, so it should not exceed 2000 megabytes per second. We can see that performance right here as well. Now taking a look at Crystal Disk Mark, KDisk Mark, and the HD Prime test, those are all artificial benchmarks and kind of give you an upper end of where you should expect the performance to be, whereas these guys over here, the file transfer tests, actual transfer of 10 1 gigabyte files, and here's the results here. So it was significantly lower in the Windows test and a little bit lower than the HD Prime test in Ubuntu. Next, I took a look at the individual SATA port performance. So I took a 2 terabyte Samsung 870 EVO 2.5-inch SSD and hooked it up to each port individually and took a HD Prime test across each of those ports. And the performance results are here. They're all around 530 to 540 megabytes per second, which is about the peak performance of that SSD. And we're definitely within the SATA 3 performance zone as well. So everything seems to be operating as normal across all those SATA ports individually. Next, I hooked up 6 500 gigabyte 7200 RPM hard drives and to each of the 6 ports on board. And this is the results of the average speed of each of those disks. And this is right where it should be. They do perform at about 200 megabytes per second sequential speed. This includes the artificial test, the Crystal Disk Mark, KDisk Mark, and the HD Prime test, as well as the actual file copy test over here. Now when it comes to write performance, we look at the Crystal Disk Mark results here, and we are running about 200 megabytes per second and a little bit slower in KDisk Mark and Ubuntu. But when it comes to actual file copy test, Windows 11 was lagging by quite a bit. Now I chalk that up to Windows being Windows and not really to the SATA ports themselves, because Windows tends to be a little quirky when it comes to file transfers in a lot of situations. But you look at Ubuntu here and you can see that the performance is actually up there around the 200 megabyte per second as you'd expect. Next, I combined all 6 disks in a RAID 0 stripe array. In Windows, I used Disk Management, and in Linux, I used MDAdmin. Now, each disk runs at about 200 megabytes per second, and combined in a stripe 0 array is pretty much cumulative, so we should easily be able to hit close to 1200 megabytes per second, theoretically. Now, the controllers on each of these boards, on the generic board, there's a J-Micron JMB585 chip, and on the BKHD board we're reviewing here, has an ASMedia ASM1166 chip. Now, each of these controller chips are connected through a PCIe 3.0 1x lane, which means we should not exceed 1000 megabytes per second. Now, you can see in the synthetic benchmarks with Crystal Disk Mark, KDisk Mark, and HD Parm, the generic disk actually hit right up around that 1000 megabyte per second, whereas the BKHD board was hitting around 800 megabytes per second. But when it came to actual file copies and the read performance, it actually hit, even in Windows, it hit 900 megabytes per second comparatively to 680 megabytes per second on the generic board, and it bested the generic board in each of the Ubuntu and TrueNAS tests as well. However, when it came to write performance, the J-Micron offered a little bit better performance than the BKHD board did. And lastly, let's take a look at the USB read performance, and you can see here it's pretty much 1000 megabytes per second across the board, and that tells us that it's a 10 gigabit port. Now you look at the actual file transfer performance, it's definitely a little bit less than the theoretical ones over here, but that's to be expected and usually around what you should expect across a USB port. However, when it comes to write performance, you take a look here, and while the Ubuntu seemed to run perfectly fine at over 1000 megabytes per second, when it came to Windows, again, the write performance was really pretty meager, both on the generic board and the BKHD board. So to summarize, what do I think? Well, for a budget build, I think this is a great option. Now, performance is more than adequate for controlling 6 drives in various RAID and pooled configurations through the onboard SATA ports. Now, you can actually do more if you opt for a PCIe or an M.2 adapter if you'd like, as I've seen it control up to 12 disks without an issue. It can also stream media with multiple transcodes if you take advantage of Intel QuickSync. There's lots of expansion options, including the 2.5 gigabit Ethernet ports, which is more than can be said for higher-end name brand motherboards. What is a bit disappointing, however, is the fact that the idle power consumption is about 20 watts, which is not necessarily horrible, but it could be significantly better, as I've seen many PCs with the same CPU running at about 12 watts idle. Also, the fact that the fan only runs at full speed despite having the ability to change the profile in the BIOS is a little bit disappointing as well. The 4x PCIe slot is actually closed off at the end, and it only runs at 2x PCIe speed, so why would you have a 4x PCIe slot? I don't know. And considering the fact that the N100 board that they offer actually has an open end on the PCIe 1x slot, as well as they also separate the SATA ports back here, and they don't do that on this guy here, so it can't easily accommodate a card to slot in between the SATA ports. With all that said, overall, unless you have a specific need for the PCIe 4x slot, I think the generic N5105 motherboard with the 2 M.2 slots is actually the better buy. Well, that's all for now. I hope you found this helpful, and until next time, talk to you later.